Hello and welcome to another Math VMK from www.mathicknows.com. If you find my videos helpful and you'd like to support my website, please go to www.mathickknows.com and click on any of the ads found on the side or click on the PayPal icon. In this VMK, I'll be discussing how to calculate the perpendicular in a two-dimensional scene. So, to find a 2D perpendicular line, we have to start with something. And we usually start with either 2 points, an equation, or a point and a direction. Now, each of these three options will give us a line in 2D space. When we have that line, we need to find the direction of that line. And I'm just going to call the direction here the x component dx and the y component dy. There are always two solutions to the perpendicular, and the solution is either minus dy dx or dy minus dx. So only difference here is this minus sign. So if we have the direction to find the perpendicular, we just flip the direction components and put a minus sign in either at the x component or at the y component. Let's go through the steps on how to get the direction of a line. If you're given 2 points, so let's say you have vertex 1 and vertex 2, vertex 1 in two-dimensional space will have an x-coordinate and a y-coordinate, so we'll just label them x1 and y1. And vertex 2 will also have an x and a y-coordinate in two-dimensional space, so we label it x2 and y2. The direction of the line between vertex 1 and vertex 2 can be calculated using this formula. x2 minus x1 is the x value, and y2 minus y1 gives you the y value of the direction. So dx is equal to x2 minus x1, and dy is equal to y2 minus y1. If instead you're given an equation, such as y equals mx plus b, this is the general equation of a line in two-dimensional space, then you can get the direction of this line by the following. You can set the x value of the direction to be 1, and the y value, set it equal to m. So whatever m value here in the equation is, that's what you set for the y value here. So dx is equal to 1 and dy is equal to m. So once you have the direction, you can go and find the two solutions for the perpendicular. So on this graph, I show you we have a vertex here, vertex 1, and we have a second vertex, vertex 2. We calculated the direction using the formula shown before, so the direction will give us the vector between v1 to v2 here. It's shown in red, and I've labeled it d. So now that we have d, we can go calculate the two solutions for the perpendicular. And again, the formula for the perpendicular is minus dy dx, and the other one is dy minus dx. So you see here, this perpendicular to our original line is labeled P1, so that's P1. And the other perpendicular is the negative of this one. So P2 is actually equal to minus P1. And you can see in 2D, this means that it's pointing on the other side of our original line. Now, usually in two-dimensional games, it's helpful to have a unit length perpendicular rather than the perpendicular which we get from our equation that I showed here. If we just use this perpendicular value, the length of this perpendicular is actually dependent on how far these two original points are from one another. So to avoid having an arbitrary length perpendicular, what we do is we get a unit length perpendicular. And to do that, we use the following formula. So if we have a perpendicular, and I've relabeled it now to be px is the x-coordinate of the perpendicular, and py is the y-coordinate of the perpendicular. To get the unit length perpendicular, we do the following. We take the x component and divide it by the magnitude, and we take the y component and divide it by the magnitude. And the magnitude of the perpendicular is equal to the square root of px times px, so px squared, plus py times py squared. So after you have the magnitude of the perpendicular, you just take each of the components of the perpendicular and divide it by the magnitude. Doing this will give you a unit length perpendicular. And you can double check it. After you get this value, you could then take this value, square it, and add it to this value squared. And then if you square root that total value, you should get 1. That's just a way to double check to make sure that you have a unit length perpendicular. And that's all that there is to perpendiculars in two-dimensional space. Now let's take a look at an example. Let's say you have 2 points, points 32 and 0.75, and I've labeled them here on this plot. So V1 is 32 and V2 is 75. We need to calculate the direction between these two vertices. We use the equations that I showed you at the beginning, and we get the direction is equal to 4, 3. So when we start at vertex 1, we move 4 units in the x and 3 units up to get to vertex 2. That's how the direction is defined. Now that we have the direction, we can go and calculate the perpendicular. So the perpendicular that we'll calculate is the first one. We take minus dy dx. So our direction here was 4, 3, so our perpendicular is minus 3, 4. We normalize the perpendicular to get a unit length perpendicular. So first we need to find the length of the perpendicular. So using these values here, minus 3 and 4, we square each of them and add them together. So we get 25. 3 squared is 9, plus 4 squared is 16. 9 plus 16 is 25. 25 square rooted gives us 5. So the length of our perpendicular is 5, which means we have to take each of these components here and divide them by 5. So our unit length perpendicular 1 is equal to minus 3 over 5 and 4 over 5. That gives us this unit length perpendicular. The other one is the negative of the first one. So we get 3 over 5 and then minus 4 over 5. And there you go. That's all you need to know to get perpendiculars in two-dimensional space.